All right, I am going to go ahead and start to work through this review. Obviously, if you want to fast forward or just kind of, just fast forward and make sure that you got all your answers correct, that's fine with me. But if you missed something, please go back and double check your answers. So, hey, let's get into it. Taking a look at the first question. Maggie wants to plan a circular bed within a triangular area set off by 3 pathways. What it's going to look like is this. If you have a circular bed set off by 3 pathways, the question then is, which point of concurrency related to triangles would she use for her center of the largest circle that would fit inside the triangle? Okay. Well, remember, the angle bisectors are the ones that make up the inscribed circle. Okay. And so if I go ahead and draw this in here, this point, because it's inscribed, is called the incenter. So this is the incenter. Okay. The next one, we have point K is the centroid. Now remember, the centroid is from a vertex to the median. So if I go ahead and do this, these lengths are all the same. Okay. So I know CG right off the bat is going to be 9. So CG is not there, but CD is. So if this is 9 and this is 9, that's going to be 18. Okay. We're told that DK is 16. Okay. Remember that there are 2 parts from the vertex to the centroid and 1 part from the centroid to the other endpoint. So if this is 16, this is going to be 8. And then FG, the whole length, again, 2 parts here, 1 part here. This is going to be 6. So FG is equal to 18. Okay. The incenter is formed again by the angle bisectors, so I might as well go ahead and mark those. The incenter. Okay. And so DH, and the incenter is also equidistant from the sides. So these lengths right here are all the same distance. So if we want to find DH, I'm going to look at GH is 11, so this is 11. BD, where's BD at? BD is that length there. Now, do we have any way? I think that this picture, oh, it's 11. Well, this is not fair. I would not give this to you guys on a test, but if I were to take this triangle out right here, here's what it is. This is a length of 11, okay? Now, later on in this textbook, we're going to talk about 30, 60, 90 triangles. And they have the rule, the 30 side opposite the 30 is x, the hypotenuse is 2x, and the longer leg across from the 60 is x radical 3. Okay, that's the rule. So from here, if 11 is here, then this length is 11 radical 3, because that's what x is, and this length would be 22. So this is 22 here, and this is 11 radical 3. So don't be concerned. If none of that made sense to you, delete all of it. I wouldn't give it to you, okay? HAC, okay, well, if this and this is 30, so that'd be 60 here for angle ABC. 28 and 28, that's 56. So HAC, if I go ahead and find this last angle and divide that by 2, that will give me HAC. So if I do 180 minus 60 minus 56, the 2/28, divided by 2, that should give me the measure of angle HAC. So 120 minus 60 would be 60, so 64 divided by 2. Off the top of my head, I think that's 32 degrees. Okay. Angle DHG. DHG, well, if this is 30 and this is 90, that's 60 right there. And this is also 60 right here. So there's 120 degrees right there for DHG. 120. Okay. Angle TQR. TQR is that angle right there. Now here's what I want you to see. This point is the same distance from both sides of the angle. So as a result, Well, we could probably, let's just prove the triangle is congruent by hypotenuse leg. Therefore, this angle and this angle have to be the same. So I'm going to say it's 43 degrees. Okay. XZ. Well, these two lengths have to be equal. This point lies on the angle bisector. It's got to be the same distance from the sides of the angle. So therefore, 3x plus 5 is equal to 5x minus 7. Subtracting 3x and adding 7 and dividing by 2, we get x is equal to 6. Now remember, don't forget to plug it back in. So xz will equal 3 times 6 plus 5, 23 is going to be the length of, sorry, I'm off the page now, off the video. 23 is your length of xz, okay? Number 11, the distance from the Tonopah to the Round Mountain is equal. So I'm going to write that Round Mountain, Tonopah, is equal to Tonopah to Warm Springs. Okay, so we're going to mark those two equal to each other. The distance from Tonopah to Hawthorne is the same distance as Tonopah to Beatty. Okay. Let's see here. Determine which distance is greater. Is it Round Mountain to Hawthorne? So is this distance greater? Or is this distance greater? Okay. Now, you can probably tell just by looking at it, but if we have side angle side, and this angle is smaller than this angle, actually let's do it backwards. If this angle is bigger than this angle, then this side right here is bigger than this side right here. So which distance is greater? I'm going to go with Warm Springs to Beatty, or Beatty, however you want to pronounce that. Okay. Number 12, we have two angles here, and what we're looking at here is that AB is smaller than BC. So I'm going to put AB is smaller than BC. Okay. And so if that's true, I'm not sure why I put, I'm basically looking at, I need to find a range of possible values for x. So I'm going to say that x is going to be less than 3x. Okay. Maybe this one isn't solvable. If I subtract, no, it's not solvable really. So I know what it was. So if this number is smaller than this number, which it's always going to be because this one's 3 times the measure of that number, then I know that this side is going to be smaller than that side right there. So you can either have AB is less than BC, or you can have that BC is greater than AB. Either way would be fine with me. Okay. The next one, we're looking at angle SRRST, so this angle right here, versus JKL, this angle right here. Okay. Now the first thing I'm going to do, I'm going to mark out the 2 8s and the 2 10s. Notice that the angles are both included between those. And then I'm going to look at the opposite sides. Okay. Now what I notice is that RT is bigger than LJ. So RT is bigger than LJ. So as a result, I know that angle RST has got to be greater than angle JKL. Okay? You could also write that backwards. Angle JKL is less than angle RST. Okay? Works both ways. All right, on to the back side. Okay? And looking at the backside, it says determine the range of possible values of k could have in the following problem. So if I look at this, I know that since we have side angle side and side angle side, that this side right here being smaller than this side makes this angle smaller than this angle. So again, I might want to just point that relationship there. So I'm going to write down 5k minus 12 is smaller than 38. Okay? Now, if I add 12 to both sides, I get 50. And I know k has to be less than 10 if I divide both sides by 5, okay? But I also have to determine what k has to be bigger than, right? If it's got to be smaller, okay, it can't be a negative value. So I'm going to go ahead and I'm going to say that 5k minus 12 must also be greater than 0. Okay, there's no way that angle could be 0 degrees. So I'm going to add 12 to both sides, and I'm going to divide by 5, and when I do that, I get 2.4. So the range for k must be bigger than 2.4, but less than 10. Okay? Must be bigger than 2.4, but less than 10. So one thing we could do to test this, let's say I chose 11. If I plug in 11 here, 55 minus 12 gives me 43, okay? 43 is bigger than 38. So we can tell that, yep, that's why it's the top bound range, okay? Let's say it's less than 2.4. Let's make it 2. If I make 5k, 5 times 2 is 10, minus 12, that's negative 2. You can't have a negative degree there, okay? So those are the range of possibilities. Number 15, length of two sides is 5 and 11. What's the range of the possible lengths of the third side? Well, we could say that the third side is the longest side, or we could say that the third side is one of the shorter sides. If I do that, I get this and this. So I know that x has to be greater than 6, but less than 16. And it looks like C, unless I didn't look at that right. Yep, looks like C is my correct answer. Okay. If the measure of two sides of a triangle are 3.1 and 4.6, what's the least possible whole number measure of the third side? Well, here's an easy way. I can get rid of those two. It's got to be a whole number. And I'm going to go ahead and do 3.1 plus 4.6 must be greater than x, and 3.1 plus x must be greater than 4.6. So this will give us 7.7. So we know x has to be less than 7.7. So that actually gets rid of number 8. If I subtract 3.1, I get 1.5. And smallest possible whole number, you can tell it's got to be bigger than 1.5 but less than 7.7. I'm going to go with 2, or B. Okay. Determine the measure. Use the figure to determine which angle has the greatest measure. So in number 17, we're looking at 1, 5, and 6. 1, 5, and 6. Well, has the greatest measure, so keep that in mind. If I were to go ahead and redraw the triangle that kind of encompasses those, here's angle 5, it kind of comes down through there. Here's angle 6, and here's angle 1. Angle 1, since angle 1 is equal to angles 3, 5, and 6 added together, I know that angle 1 has to be the greatest, bigger than 5, and angle 1 is greater than angle 6. Okay, so angle 1 is the answer there. Oh, sorry. Get a little carried away. All right. Number 18, if I look at 9, 8, and 3, 9, 8, and 3, okay, we know that 9 is 90 degrees, okay? And we also know that 8 is bigger than this angle, which these are the same, okay, is bigger than this angle because it's an exterior angle. We also know that 8 is bigger than 2, 3, and 5 individually because this is a exterior angle. This is a remote interior angle, okay? So I'm going to go with angle 8 there. And you can tell it's obtuse. 4, 3, and 2. 4, 3, and 2. I'm going to say in a triangle, the right angle, if we have a right angle, it's going to be the biggest of the 3. If we have an obtuse angle, it'll be the biggest of the 3 as well. So angle 4 is going to be the largest there for number 19. Which segment is the shortest in the following figure? Let's see here. I'm going to go with, if I add these together, 80 and 15, so that'd be 95. No, that can't be right. 95 from 180 would make 85. There you go. That looks better. Okay. 135 from 180 gives you 45 degrees. Which segment is the shortest in this triangle? The shortest is that side right there. In this triangle, it is this side right here. I about looked at that wrong. Okay. So as a result, I'm going to say that since we know that XY is the shortest in this triangle because of the 47 degrees, that it is shorter than YW, even though this is a smaller angle, if we've already proven that XY is the shortest in that triangle. So I'm going to say XY is smaller than YW, and I'm going to say XY is the smallest. Okay? All right, on this last one, all right, let's see here. If we take a look at the proof. All right, so on the last proof, okay, there will be one proof on your chapter test, but it will be a fill-in-the-blank proof. And so let's just familiarize ourselves with what's going on. XW is equal to YZ. So XW equals YZ. We're told that XK is bigger than WK. Makes sense, it even looks that way. And that KZ is bigger than KY. Okay, I'm not sure I would have guessed that, but that's what they're telling us. Now, they're taking this statement right here and saying if they're equal, then they have to be congruent. And if you remember from the beginning of the year, this is called the definition of congruence. If they are equal, then they are congruent. Likewise, if they're congruent, then they're equal. The next one, and I don't really like how this one is laid out. The one I give you won't be laid out like this. If I didn't already state it, the one on your test will have a word bank. Okay, but here's what it says. It says XZ is larger than WY. So what they did here, they took these two segments that were both bigger, XK and KZ, added them together to make XZ. And they took the smaller segments, YK and KW, added them together to get WY. And yes, this is going to be true. And this is called the addition property of inequality. What that means is that when two things are always greater, like these were already greater, when you add them together, they're still going to be greater. Okay? The next one is the reflexive property. Hopefully you recognize that one, remember that one. Okay, so right now, what we're looking at are these two triangles. This one right here, ZYW, and this one is bigger, is smaller than, and this one was WXZ. Okay, so this one was bigger than this one. Okay, so as a result, we know that XWZ is going to be bigger than YZW because this side was bigger than this side, and that is the converse of the hinge theorem. We'll probably talk in class about how that opens up. Bigger side makes bigger angle. Okay, so that's the converse there. All right, I know that took a while, but I wanted you to get through everything. I hope that made sense. If not, come back, let's talk. Okay, hey, have a good night. Bye.